Our world is filled with brilliant phenomena, small things that happen continuously, discoveries that we could barely ever imagine. The scientific community is so wide and broad, and yet we tend to prefer to keep our attention rooted on the strange, unusual, and sometimes somewhat bizarre events. Often we gloss over the world of physics because if we don't have an understanding already, these sensationalist headlines marking fantastic discoveries can seem somewhat meaningless. So today, here at Unexplained Mysteries, we will be looking at 3 recent discoveries from the world of physics. Physicists just achieved a new smallest measurement of a ghost particle's mass. We may have learnt about electrons and protons at school, looking at the negative and positive charges within atoms in the revolutionary work that is being pushed through currently. Researchers are delving into far more difficult to understand aspects of these particles of matter, trying to inch us that little bit closer to a finding that can answer lingering questions about our universe. Neutrinos, which have earned themselves the nickname of ghost particles, are subatomic particles that are notoriously difficult to work with, understand, and next to impossible to detect, all thanks to their incredibly elusive nature. So far, we know of 3 different types of neutrinos, each one with an opposing subatomic particle, those being the electron, muon, and tau particle. Neutrinos have an incredibly tiny microscopic mass, falling at being close to 0, and have a half-integral spin. This means that their interactions with normal matter are incredibly scarce and hard to come by. Billions are known to be passing through even each person's body at any given point in time, and even though we know they are there in abundance, they are still relentlessly difficult to detect. Researchers have developed some ways in which we can detect the presence of neutrinos, though they are indirect methods recording and observing the effects neutrinos have on their neighboring particles as they pass by, not actually detecting the neutrinos themselves. Methods like that just described include the Cherenkov neutrino detectors, a system that has confirmed plenty of suspicions and highlighted just how difficult it can be to investigate anything regarding these elusive ghost particles. Of course, it goes without saying that measuring the so-called ghost particle brings a whole new host of challenges that one should not underestimate the difficulties of. We have been inching our way closer, taking measurements from the little information that we do have and working our way inwards. Now, however, scientists have been able to refine that search a little, narrowing the range at which the mass of the neutrino might fall into by just a little more. Whilst it sounds like a minor achievement on the surface, it brings us a major step closer to something that would have a monumental impact upon our understanding of the universe and has already allowed us to draw our measurements and understanding inwards, making our understanding that much more accurate. Let us look how these measurements were taken. Physicists were able to determine that the electron antineutrino has an upper limit of 0.8 electron volts, a microscopic number clocking in at just 1.6 times 10 to the power of minus 36 in metric mass measurements. This was done by measuring the distribution of electrons that were released throughout the beta decay of tritium, an unstable radioactive isotope of hydrogen. This is our smallest ever measurement of the mass of a neutrino. This new data was obtained at the Karlsruhe tritium neutrino experiment, also known as Katrin, based in Germany, with the research team's findings being displayed in their paper, which was published in Nature Physics in February of 2022. All the data we have regarding the mass of a neutrino sits on the crux that a particle and its antiparticle, in this case an electron, have an even distribution of both mass and energy. This means that the observations and measurements were initially taken of electrons and then adjusted accordingly to represent that of the neutrinos. The same research team plans to continue this experiment, increasing the statistics of signal events to refine this number even further, with the existing plan seeing measurements of the ghost particle's mass taking place up until late 2024. This complex discovery might have been tiny in the data collected, but will have massive impacts upon the scientific world. Physicists find particles that switch between matter and antimatter. Some theorize that when there was the Big Bang, there was an equal amount of antimatter put into the universe as there was matter, which is how the neutrinos were able to be measured via the electrons in the previous study we looked at. Antiparticles are where the subatomic particles each have the same mass but the opposite electric or magnetic properties, respectively. This idea feeds into the equal and opposite rules that we see crop up time and time again throughout the world of physics. Now, however, scientists believe that they may have found some particles that are able to switch between matter and antimatter, inverting their own electric and magnetic properties. This study was conducted using charm mesons, which are subatomic particles containing both quarks and antiquarks, and was carried out using the Large Hadron Collider at CERN. Up until now, it was believed that charm meson moved as a combination of matter and antimatter, though a more accurate understanding appears to be that they can fluctuate and switch between the two different states. This was found thanks to their incredibly tiny mass and measurements taken from proton collisions. Charm meson particles are formed when protons collide with other protons, and the window in which to take observations is minuscule, as they move just a few millimeters before they turn into different particles. Comparisons were drawn between these particles and those that moved a slightly further difference, which led to a difference in mass between those that were slightly heavier and those that were lighter. While this difference in mass was minute, it was enough to realize we were observing quarks and antiquarks, a transition between matter and antimatter rather than a difference of mass and distance traveled. In terms of future research, this has the potential to facilitate a new understanding of the Big Bang, in that there was not matter and antimatter produced in equal quantities, but rather we are able to observe a great deal more matter than we are antimatter. Dr. Mark Williams, a researcher with the University of Edinburgh, said, "Tiny measurements like this can tell you big things about the universe that you didn't expect." Stars made of antimatter might be lurking in the universe. We have already looked at the theory that antimatter and matter should exist equally in the universe, and as scientists remain divided on this topic, we still have a glaring lack of antimatter that we have managed to observe in the universe, despite their presence in research experiments. In 2018, the Alpha Magnetic Spectrometer experiment, a piece of equipment fitted to the side of the International Space Station, managed to detect 2 antihelium nuclei. It is difficult to imagine any sort of scenario in which we can spot such extreme amounts of antimatter with this equipment, since we would not think it possible to observe such an abundance of antimatter that was formed naturally, and not through a controlled experimental environment. Despite this strange scenario, one of the seemingly most plausible theories is that this large amount of antihelium was formed within an anti-star. As far as we know, anti-stars do not exist. This rogue piece of data is yet to be confirmed. Researchers leapt into action trying to calculate the likely, the plausible, and the probable explanations. In 2021, a group of researchers even published a study calculating the maximum number of these hypothetical antimatter stars that could be out there in the universe, if these were the culprits behind several unexplained gamma-ray sources detected by the Fermi Large Area Telescope. Despite the wide level of skepticism regarding the very existence of these stars, the possibility of them being found is truly thrilling. From the idea of these weird, inverted stars out there to an explanation that could provide a whole new piece of evidence to the Big Bang Theory. The scientific world is continuously advancing, and some of the biggest discoveries in the field can seemingly mean nothing to us here at home. Whether it's a tiny new measurement or a finding from way out in space, there is so much work going on within the realm of physics. But what are your thoughts on these discoveries? Be sure to let us know in the comment section below and help us grow this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.